My name is James Chadwick, born in Bollington, England in 1981, and I shall tell a very, very brief summary of my life story. You see, I had applied to Manchester to study mathematics, but instead I was accidentally interviewed as a physics student. And of course, I was a very shy man back then. Obviously, I could not have corrected them. And it's all as well, because I met Ernest Rutherford. Great man, except for that one bitter quarrel where he absolutely would not agree to having a cyclotron particle accelerator at Cambridge. But of course, I'm getting ahead of myself. I would often do my projects in his laboratory. We would discuss topics and do downright silly experiments together. But of course, that was before I went to Germany on scholarship and partnered up with Hans Geiger, where we discovered that electrons are emitted in a continuous spectrum. But then, of course, World War I had to break out, and I was interned there for the rest of the war. I remember that some other fellows and I convinced the gods to let us construct a science lab of sorts, and to get us chemicals that were hard to acquire at that time. It was really a miracle how we did it, but as soon as I returned, I began working as an assistant director in the Cavendish laboratory with Rutherford, which of course was much more well facilitated. But it wasn't Rutherford that influenced my discovery of the neutron. And yes, of course, I discovered the neutron. You see, this experiment by Frederick and Irene Joliot-Curie sparked my interest. They were bombarding beryllium with alpha particles, which causes the beryllium to emit radiation. The Joliot-Curies thought that this radiation must be consisted of high-energy gamma photons. But you see, this radiation also loses photons from hydrogen atoms. Photons won't be able to do this, they have no mass. So, in 1932, I worked tirelessly on this experiment, knocking loose protons, bombarding beryllium tirelessly. And not just beryllium, I worked with lithium, helium, nitrogen. Within a month, I had the proof of a new particle inside the atom, slightly more massive than the proton, the neutron. I was awarded the Hughes Medal of the Royal Society and the Nobel Prize for Physics for this discovery, and knighted in 1945. You see, the discovery of the neutron made possible nuclear fission, which Otto Hahn experimented quite a lot with and eventually split uranium-235, which made the atomic bomb possible. I was, in fact, the head of the British mission in the Manhattan Project, which the US poured millions of dollars into research on the atomic bomb. It is possible, of course, that nuclear weapons are created, even inevitable, as our sciences have already advanced enough to make it happen. In the Manhattan Project, I maintained friendly British relations with the US and made sure British scientists' morale was upheld. Quite a job, I tell you. I almost wished the bomb wasn't made. It was quite astonishing to see my own discovery materialize itself with such telling effect on the destiny of man, if I might borrow some words from William Lawrence, a fellow New York Times reporter on this project. I have received the Copley Medal in 1950 and the Franklin Medal of the Franklin Institute, Philadelphia, in 1951. I am an honorary fellow of the Institute of Physics, and I received honorary doctorate degrees from multiple universities. That is a brief summary of my life in the science aspect. Thank you.